Greetings, fellow classmates and lecturers. We are Group G, and the topic we have chosen to present is on structural reinforcement. Structural reinforcements are used when the maximum load capacity is reached for existing buildings. It is a much cheaper and viable option compared to erecting new buildings. Examples of structural reinforcement include steel reinforced concrete, glass fiber reinforced concrete, etc. For the reinforcement to fulfill its function in the construction industry, it needs to have the following properties at least: high relative strength, high tolerance of tensile strain, good bond to the concrete, which is irrespective of pH, moisture, and other similar factors, the durability in the concrete environment, irrespective of corrosion or sustained stress, for example, as well as thermal compatibility. We will be pitching our chosen material, steel reinforced concrete, which we think is the ideal material for structural reinforcement. So how is it made? It's made by setting up a steel framework on a construction site, and then by pouring concrete over it. Now, we will be discussing about the properties of steel reinforced concrete. So why use steel reinforced concrete? It's because, firstly, steel reinforced concrete has high strength and tolerance because it is able to absorb the tensile, shear, and compressive stresses applied on it. Since reinforced concrete is a composite material, it has the characteristics of the materials that made it. Thus, reinforced concrete is able to resist both compression and tension force. Secondly, we will discuss about the strong bond between steel and concrete in steel reinforced concrete. When the cement paste within the concrete hardens, it will conform to the surface details of the steel. The bond between steel and concrete is affected by their thermal expansion coefficient, which is the rate a material expands as a function of temperature. Thirdly, steel and concrete have similar coefficients of thermal expansion, which means it expands or contracts at almost the same rate. This also means that steel will not crack the concrete that surrounds it like another material would if it expanded more or less. Thus, they are thermally compatible. Lastly, steel reinforced concrete is durable, which means it is able to serve its intended purpose for extended periods of time. It has a lasting period of about 50 to 100 years. Now, we'll be talking about a comparison of steel reinforced concrete and other materials used in the industry. Is concrete. The first comparison we are using is concrete. Steel reinforced concrete has a higher tensile strength, higher post-crack flexural strength, better crack resistance, improved fatigue strength, higher resistance to spalling, and better first crack strength. Reinforced concrete such as steel reinforced concrete was invented in order to improve such qualities that concrete lacked. Steel reinforced concrete also has a shorter lifespan due to corrosion of steel in the frame, about 50 to 100 years. Lastly, steel reinforced concrete has better ductility due to the steel inside, allowing it to resist bending. The second comparison is with glass fiber reinforced concrete. Steel reinforced concrete is able to resist compression, bending, and other tensile actions, while glass fiber reinforced concrete is only able to resist compression and tension. Steel reinforced concrete has good ductility due to the steel framework. Glass fiber reinforced concrete requires more skill to set up, as it requires the contractor to mix in the fibers into the cement, while steel reinforced concrete is much easier to set up, only requiring the setting up of the steel framework. Steel reinforced concrete has less durability, as the steel inside the concrete can rust from cracks in the concrete. However, glass doesn't rust, so this doesn't occur. After countless comparisons and research, we came to a conclusion that steel reinforced concrete is the ideal material to be used in the industry, because compared to other materials, steel reinforced concrete offers some of the best properties that is required for structural reinforcement in the construction industry. For its price, the benefit it offers us is remarkable. For example, steel reinforced concrete is one of the most durable reinforced structures in the industry. Moreover, it can be molded to any shape required, which allows it to be used in many different situations where structural reinforcements are needed. In conclusion, these are the reasons why steel reinforced concrete is the most ideal material to use.